Hi guys, Pete here, and I want to cover in this video a recent acquisition is a SWAN 140, one of the monobanders, early rigs from SWAN Radio there or SWAN Engineering there in Benson, Arizona. This back of this does say it was made in Benson, but it may have been a transition piece as he moved over to Oceanside. I saw this on eBay and it was quite pricey, and after a while the seller reduced the price significantly, and I kept looking at it, and nobody was bidding on it, no one was buying it now. And so I said, well, I have a SWAN 120 and I have a SWAN 175, so this would complete the collection. Those were the first three models that were made, the 120, 140, and 175. So it worked pretty good. The rig was advertised as for parts only, did not work, no power, and so I'm not sure what that was all about. But first thing I did when I did acquire this was, it was filthy inside, and I sort of cleaned it up, and this is a lot better. It had 10 tons of dust on it. As you can see here in the later models, they really put a cover over the complete complete final amplifier. This they didn't, because this capacitor here that's exposed, the way it was designed, it's an interference fit. So later ones, what they did is they just made a cover with a blip over the top of it to take care of this capacitor problem. It's got a 6DQ5 and the final will do about 100 watts. So let me tell you what the first problem that I saw was. The first problem I saw dealt with the cathode meter here, this receive transmit, and this carrier balance. In normal operation, if you just hit the switch here, it shows a level of carrier balance, and you're able to balance it. You see it there to about 25 mils, which is the set point. I'm able to set that with a bias pot in the back here to 25 mils. But what was happening is, if you move this control full clockwise, you get almost a full deflection of the cathode meter, which means you got carrier coming out of the unbalanced carrier, and you got the full. If you turned it the other way, counterclockwise, you'd get just a small blip. It was just beyond the carrier null, port, but it was not like it should be in, more or less in the center. Here, let me demonstrate that to you. Okay, you see it goes to one side and then goes to the other side. Well, it wasn't doing that. It would only go to one side, and when you went to the counterclockwise, you'd only get a small cathode current indication. Now, the way the balanced modulator tube is, it's a 7360, which is this tube right here. This is a vacuum tube version of the ADE1 SBL1 tough one, so it can be used as a mixer, product detector, or balanced modulator. And quite an innovation. They came out with a little cheaper variants of a 6AR8 and 6JH8, but they're not like a 7360. Later SWAN design went from the 7360, which the tubes were getting to be pretty expensive, to the 6AR8, 6JH8. Matter of fact, the SWAN 350's got the 6JH8 in it. So anyway, I saw that as a problem, and I'm going to show you a little later. There's I hand drawn a schematic. Essentially, what you have on these two deflectors, there's two deflectors, pins 8 and 9. It's almost like a bridge. They've got 6 resistors in there, and essentially what you do is you balance the bridge. And when you balance the bridge, you have a carrier null. And I'll show you that in the circuit diagram. So that was the first thing I fixed. And the major problem was this jewel, a 100K resistor. And that's part of the bridge. And when I pulled this out of the circuit and measured this, it doesn't look burnt or bent or, smoked or anything like that. It looks like it's okay. It measures 20K. So I don't know how it got to be 20K, but those are not precision resistors. They have the silver band on them, not the gold band. So you can tell that they were like 10%. So anyway, I replaced that with a proper 100K resistor, gold band, and guess what? It works. And I've had a couple on-the-air contacts on it. The dial is surprisingly linear. In other words, you can put a signal generator. When you go to 7220, it'll read 7220. When you go to 7200, now it may be off just slightly, but it's pretty good linearity across the dial. Unlike a lot of radios of this vintage, like the Helicrafters and National, they did not have a linear VFO, and this one was pretty close on. I guess I spent a little more time, I could do that, but this whole enclosure right here is just a VFO, and they got one tube in there, and they got an air ducts coil, and they got a kind of another coil in parallel or series with it, so you can do one thing with that series, and it's got a patter. The patter capacitor will put it on the right frequency. The second small inductor, which here's the second small inductor right here. You can get one of those little plastic tune wands, and here's the one that set it at the location. But that in small inductor in series with the large mini ducts sets the linearity between the spaces. So you have to adjust the inductor to get the linearity, so it'll read 7200 and 7220, and the small little pattern capacitor will put it on 7200. Does not have an S meter, does not have an AVC, and although it says volume control, it's really the RF gain control in the cathode of the RF amplifier. So you have this thing up at full volume, boy, it just distorts, and you crank it back and just everything clears up. There was a little AGC mod for this, and I put it in other radios, but it didn't work that well, but they did try to address that problem. But remember, this thing was trying to be put out as cheap as possible. Another view here, this is the filter. It's 5773, and kind of interesting. The VFO is actually on 12 megahertz, so 12 minus 5 gives you 7. And that same filter was used in the 175 and the 120, and there they used the 9 megahertz filter, and they did the old trick. The 9 plus the 5 gives you 14, and it gives you upper sideband. The 9 minus the 5 gives you 4, which is lower sideband, because they have a sideband inversion. So I used the same filter, same BFO crystal, which is right there, and was able to get 2 bands. And then on the 40 meter one, it's kind of different. As a matter of fact, the SWAN 240, where they just essentially combined the 175, 140, 120 into one radio. Essentially what they did is they had a switch right here that switched to VFO. So on 80 and 20, the VFO was in the range of 9 megahertz, and so when you went to the band, it would either be lower sideband or upper sideband. And on 40 meters, that band switched the VFO range to 12 megahertz. So it's kind of interesting how they did that. The standard tune and load. Some of the construction is a little crude. This is like a butterfly capacitor, only he homebrewed one. He got two different small variable capacitors on the exciter tune, and he just soldered a copper or brass bar between the two. So the brass bar is in the slot of one and is on the rotor of the other one, and that's how you're able to tune this thing. And then later versions did actually have a butterfly type of capacitor that you could tune 2 sections, but this one tunes a little stiff because you actually have 2 capacitors on a shaft that you're tuning. Has a tune control here. You hit the tune, and we'll do that. You see it's 250 mils, and that's about normal, and you get about 100 watts out. And with the screen voltage, it's around 260. I have a Heathkit supply that has 2 levels of screen voltage. If you put the higher voltage in there, you can get 120 watts out of this thing, although you're probably shortening the tube life. This one big tube right here is an OD3 VR150, which is a voltage regulator for the VFO. This other big tube here is 6V6 audio tube, and that can put out almost 5 watts. So anyway, there it is with no signal, and that's the RF gain control. So still a little more work to do on it, but I've had a lengthy conversation last night on 40 meters, and it was really a delight to operate this, and I'm sure glad I got this one. Actually, I bought the 175 with the idea of converting it to, because of the subtractive nature of the VFO. You wouldn't have to change the VFO or the BFO, but if you change some coils, you could put it on 20 meters. So I was thinking of maybe converting that to 20 and then get rid of the VFO and put an SI 5351 in there. The audio sounds really good from this on transmit. You get good signal reports on transmit. So this is what you might have mounted in your car, vintage early 1960s. And I had one in my automobile in the early 70s, or late 60s, early 70s. And I used a Drake DC3 power supply, just rewired the plug, and it's enough to put this thing on the air. It gets you about 80, 90 watts. So anyway, this is Pete, N6QW, and this is the SWAN 140 that I just acquired, cleaned up. And so all the money I've spent is to replace one resistor so far, and everything seems to be working good. So stay tuned for more fun and adventures with these old-time boat anchors.
That's one reason I only have a 40 watts to 50 watt peak, that's the reason for that. So, okay, well, I appreciate very much the contact, Tack. Take care of yourself, and I'll try and check in some other time when I hear you on the band again. Kilo Nancy 6 radio here, X-ray. This is X-ray Echo 2 Alpha Foxtrot Tango. Over.
Roger, Roger. Well, thanks again for jumping in, and don't be bashful. You're welcome anytime, and people might, if you're not careful, if you hang in there a little bit, you might get a call. There's probably some people looking for Mexico, so hang in there tight if you can. If not, please come back and join us, and again, appreciate you coming in. Okay, with that said, I'll be bringing on a new friend Art there. It took me a little while to get that one straightened out, and he's X-ray Echo 2 Alpha Foxtrot Tango. And with that, I'm going to make one more call before I turn over my good friend Alan there in Arizona. This is Kilo November 6, Romeo Sierra X-ray for the wireless system, and I'm looking for check-ins for the 40-meter West Coast session.
November 6, Foxtrot, Romeo X-ray.
Okay, November 6 Foxtrot, caught me off guard. Come back again.
Yeah, November 6, Foxtrot, Romeo X-ray.
Is that Romeo X-ray or Whiskey X-ray?
Romeo X-ray.
All right, got you in there, Tom. How you doing tonight?
Tom, do. Excellent. Well, I just wanted to check in and get on the log. No calls, and that's about it. 7 strings to all in 6 FRs.
Roger, Roger, Tom. Well, thanks for jumping in. Good hearing from you again, and always nice to have you in there. And that's it. Hey, I'll be bringing my good friend Tom, neighborhood here in El Cajon. He is November 6th, Foxtrot Romeo Mike. And, I'm sorry, Romeo X-ray. I'll tell you. I don't know how I'm doing it tonight, but I'm managing. Let's see, Alan, I hope you're feeling okay there in Arizona. I'm going to send it to you. QX-ray 7, QX-ray. Take it over, Alan.
Okay, Roger. Yeah, I'm good.
He confirmado un mañana por la tarde, tengo años que entro muy temprano a trabajar y pues también salgo temprano, así que no le batallo mucho por ese lado.
Hey, Mike. Here's Tommy, W7PD, KE7IR. KE7IR, W7PD.
Where's you? Kilo, Victor Kilo, Mike Romeo, Mike out in Colorado. You're up for a call.
Roger, Roger. Kilo 7. November, St. Peter will break the queue. Going to give the home state to line number
15. Good drop-off point on the way to wherever, from the vehicles to wherever it needs to go in the house.
As far as games go,